Hello everyone, my name is Kalu and I'm going to be taking you through this workshop session on serving deep neural network in Django. It's basically about how you can integrate machine learning model into a Django web app so that the inference becomes available to the end users. This is going to be a hands-on session, so let's get started right away by first building a simple deep neural network that we're going to deploy in our Django app later on. I hope you enjoy this session. So welcome to the first part of this workshop, which is where we build a deep neural network. If you're going to build a deep neural network or any other kind of model for that matter, you will usually use the Anaconda. So we're just going to load Anaconda from our system. And the Anaconda is a beautiful software because it has everything you need to do your data science and machine learning all together, all the libraries and toolkits you're going to be needing. You have the Jupyter Notebook, the NumPys, Pandas, sklearn, and all those stuff are all there, even Keras. So we'll just go ahead and launch a Jupyter Notebook is where we're going to be writing the codes for our model. So what we do is, first is always good to create a folder where you can organize all your work. So since we're creating a folder, you just get there. So I'm gonna keep this and rename it to, okay, let's call it PyCon Africa 2020 workshop deep neural network class. So it's right there. So I'm just gonna go ahead and load the deep neural network. So I'm gonna open this folder, and I like to add some other folder here. So the first folder I'm going to add here is for storing my data set. Okay, so then at the end of this workshop, we will also be saving the model we built. So let's have a folder for that. We're going to call it save model. Sometimes if I was having some assets to add to this, I could get another folder for assets, but this is okay for now. So we'll just go ahead and start a new project for Python 3. And so right here, we are about to begin building our model. So the first step is to import our dependencies, and we're going to say import dependencies. The primary dependencies are always going to be NumPy and Pandas. So I think that should be an N there. So we'll go ahead and just import NumPy as MP, and we'll also import Pandas as PD. Okay. So once we have done this, the next thing will be to read our data set into the notebook that we're going to be using. Remember that we've not included our data set. The data set we're actually using for this is from Kalu. The link is right here on the video. I've already downloaded this, so it's downloaded to my downloads folders. I'm using the Windows operating system. So what I'll just do is to upload it. I'm gonna want it to be on the data set folder, so I'm just gonna upload it. So this is the folder, this is my downloads. So this is like the folder that comes from Kalu, and I'll be using the trend, and so it's a CSV file. So I'm just gonna say open, and I will upload it. So once I upload, it's not available for me to use. So I'm going to create a new variable data. We can say pd.readCSV. So data set /trend.csv. Okay. So read CSV is just a pandas function for reading CSV file. You can read the file in different formats. So let's be sure that this worked. So I'm just going to look at the first 10 columns. Oh, so we have an error right all along. Okay, so yeah, so it worked here. We're looking at the first 10 rows in our data set, and look at all the features that make up the data set. There are about 21 columns. Okay, so what that means is that 20 features, and then the last one is the price range that we actually want to know. So using all of these features, the battery power, the whether it has Bluetooth or not, the clock speed, does it have dual SIM, the front camera megapixel value, is it 4G phone, internal memory, and all of these. There are about 20 features here that we have to put into consideration to be able to properly classify a phone either in price range 0 or price range 1 or 2 or 3, and there is actually no way we're going to have to hard code these decisions ourselves. So best thing is to have a model do this for us, and that's what we're just going to do right away. And so from what we have here, we can see that we have all of these features are going to work together for us to create this. So next thing we're going to do right now is to try and split our data set into the x and y variables. Okay, the y variable is the prediction we're trying to make, and the x variables are the features that will be needed for that prediction. So the x is what we call the independent variables, and the y is the dependent variable. So right here now, the only dependent variable is the price range. That is just the only thing that is going to be making decision about, and the whole of this is included. We might have a work where we don't need to include all the features, but here we actually need to include the whole 20 features. Are very, very important to us in this. So we're going to do that as just quickly. Just how we're going to do that is I'm going to say split data set into x and y. Okay, our x is going to be the whole of the features from first row to the 20th, from first column to the 20th column, and the way we're going to select that is we're going to use the iLock. Okay, and so what this does is it doesn't just select the rows, but it also converts this from a pandas data frame into a NumPy array at the time. So what this does is, the first one is I'm going to need to select all the rows, so column nothing, but the second one is for the column, so I'm selecting from the first to the 20th. So if we take a look at this, we will so this is done. So for y, we're gonna have data.iLock. Okay, so I'm also selecting all the rows, but I'm just gonna select the last column. So all right, so if you want to see what you have in your x right now, you can go ahead and see your x. You want to check out your y, you can see your y. So it's just here, right? So we have all of that. So we've done this. So we have split this into x and y, our data set, and then the next thing we're going to do is we're going to normalize or evenly distribute the values on our x features, because look at this, we have some of the values are way high above the others, so this is going to create a lot of inefficiency in our model. So we're going to find a way to evenly distribute these values without actually losing their proper significance. So we can do this using the standard scalar from sklearn. We can using the running logarithmic functions. But I prefer to just use the inbuilt sklearn standard scalar for something like this. So from sklearn.preprocessing import standard scalar. So we're going to do this on our x values. So let's first of all create an object of this standard scalar class. So now we can confidently say x equals a scalar dot fit transform x. So we're going to fit transform x, and then we're going to see what x looks like now. So wow, so x is kind of a big one. If you were to plot some kind of graph now of x, you will see that it will have some even distribution, unlike what we had before. Okay, then there's something else we're going to do for our y-axis. Our y-axis, okay, kind of have our y values, y-axis, essentially. So y has 4 distinct values. Okay, so it's just like 0, 1, 2, 3. If this exists like this, this is actually a categorical value. Okay, even though it has numbers in it, so it's actually a categorical value, and the way to treat a categorical value is to find a way to turn it into a numerical value that the algorithm or the model can work with. Now, if we leave this as an integer, or just leave it as the way it is, or just okay, since it's already in numbers, so let's work with it. What's going to happen is our model is going to think that 0 is a progression to, or 1 is a progression from 0 to 1, and then and 12 and so on and so forth. So it's going to actually treat this as a progression instead of as a range, and this is not going to work so well for our model. So what we're going to do is we're going to actually make this into a pure categorical value. We're going to engineer this into a categorical representation using one-hot encoding function. So from sklearn.preprocessing, so we're going to import one-hot encoder. So I will explain what one-hot encoding does briefly. So it's kind of creating binary values for representation for each of these values. All right. So as we have 1, we have 2, we have 0, we have 3. Okay. So we're just going to have this representation for 1. 1 is going to be 0 is going to be 0, 0, 0, 0, and then 1 is going to be 0, 1, 0, 0. And 2 is going to be 0, 0, 1, 0, and 3 is going to be 0, 0, 0, 1. So as the case might be. So we're just going to create an encoder class. It calls one-hot encoder. Okay, so so we'll go ahead and encode y. So y is going to be equal to encoder dot fit transform y. So we'll convert this to an array just to make it work. Okay, so it's done. And you're gonna be careful not to run this twice, because if you keep running it again, it will keep generating and encoding from the already generated encoding. So if you want to see why, make sure you do that in a separate cell. So right now we're looking at y. So you can now see that 0100 is 1, 0010 is 2, 0010 is 2, and so on and so forth. So that's our y. So we have engineered the features for the x and also for output. So this is going to actually factor into our model and the way it's going to work. Now the next thing that we're going to do now is to split our data set into training set and testing set. Now why we do this is it's important that you actually use a part of the pre-labeled data set to be able to evaluate and see if your data set is performing as it should. So what we just do here is we're going to use another inbuilt function from sklearn model selection. We're going to import a function that is called train test split. So let me try and just do some split data set into training set and testing set. Okay, so just one function is going to do this for us. So this is going to accept 4 variables. I will explain this. So it goes test train split. Okay, so before I proceed, I'm going to show you what's going on here. This test train split is going to accept the first parameter x, which is of course our x from our data set, and it's going to split it into 2, put some part as x train and some part as x test. You could actually name this anything, but this is kind of like what's named almost all the time. Okay, and then it's also going to take our y and split it into some part will become y train and some part will become y test. So how does it know to split this? We're going to prepare a test size. So 0.1 is equal as 10%. So it's going to split the data set 90-10. So the 90% of the data set will go to the training x train, y train. The 10% will go to x test, y test. Alright, so that makes sense. And if we kind of like run this, okay, let's see, that's been 0.6. Oh no, this is trend test. Trend test split, not the other way. So just watch out for little errors like this that could actually mar what you're doing. Okay, so if you want to check out, you can take a look at your X train. What does it look like? Oh, you can also look at your X test. So what this means is we now have 4 variables to work with. We now have 4 variables to work with. Oh, sorry, kind of. Okay, so we have y train and we have y test. Okay, so and we're going to be working with all of these as part of our data set of our model. So we are actually finished with pre-processing our data set. So let's go ahead and actually build the model. Let's do the fun thing. Okay, so let me convert this to a markdown and just let's build the model. All right. Okay, so we are building a deep neural network and we're going to be doing that with the Keras. So we're going to import the dependencies we will need to build this neural network. Import dependencies. So they're going to include, of course, we'll start by importing Keras. We'll import keras.models. Okay, so we're not going to actually import everything here. So let me Just go back there and say from Keras.models import sequential. So we're building a sequential model, one of the simplest neural network we can build. There are actually other ones. So let's just do it sequential, and then we are trying to use just simple dense layers. Okay, from layers import dense. Okay, so we are all inputs, matches into the output. And sequential also means that the input from one layer becomes, so the output from one layer becomes the input to the next layer. So it's just sequential, all right, the way it is. And so we're using TensorFlow backend right there. Okay, so this is fun actually. This is very fun. So we're going to build this neural network. We're going to have a deep neural network. Generally, neural network are divided into three layers: the input layer, the hidden layer, and the output layer. So the input layer is gotten from our input features. The output layer is gotten from what we're trying to predict. So where we play around is from the hidden layers. So with the more layers we add, that's just going to make things work the way we want them to work. Okay, so let's start building this model. I'm going to say model equals sequential. So we are building a sequential model. Now let's start adding layers to this model. The first layer we're going to add is the first hidden layer. Okay, so and it's a dense layer, like I mentioned, and we're going to include 16 neurons or 16 nodes at that layer, and it's going to have an input dimension of 20. So this input dimension is actually the 20 features from our X values: the battery speed, the battery power, clock speed, 4G. There are 20 features. So they are the first thing that we're going to feed into the neural network, and then the output from there is going to get to this next layer inside the hidden layer that we're going to have 16 nodes. So which will work on it. And let's go ahead and add one more layer to the hidden layer. So add the dense layer, and let's just give it 12. Okay, we don't need to specify an input dimension again, because this is a sequential layer, a sequential model. It knows that the output from this is going to automatically go to this. So we don't need to specify input dimension anymore. You're looking at some stuff. I'm typing activation. I'll talk about activation. So model, let's now add the last layer, which is our output layer 4, and then we are using soft mass here. Okay, it's output. Okay, so that's done. Believe it or not, we have built a deep neural network. Okay, so we just have two hidden layers, the one with 16 and 12. So the output layer, of course, has 4, because if we go back to our Y, you see that there are 4 different ones we need to look at: 0, 1, 0, 0. So it's going to give us 4 outputs. 4 nodes in our output, so whatever. All right, so the next stage after setting up the layers and stuff is to compile the neural network. So compiling the neural network is what actually going to make it fit in together. And right where we're doing it, we are going to provide the loss function. We're going to provide the optimizer. We're going to also provide the metrics we are very much interested in. So we just do model.compile, and we're going to specify the loss as the categorical cross entropy. Okay, and then we'll specify an optimizer as Adam. There are other ones, sigmoid and stuff like that. So metrics here is, of course, we are looking for accuracy in our metrics. Okay, so let's make sure this is working. Always helps before you progress. Okay, so now we have done this. The next thing will be to train the model. Okay, so train the model. That's the easy part. So we just do model.fit because we want to attach this to a result after training. So model.fit. We should have xtrain, ytrain to specify the epochs to be 100 and then batch size to be 64. So I'll explain this. So the xtrain and ytrain is what we're familiar with. The epochs is telling the model how many times it has to go through the data set, how many cycles it's gonna have to run. So we're gonna do this 100 times during the training process. And the batch size refers to the amount of rows that is or part of the data set. So we're gonna be picking up 64 at a time while it's doing this training. So if you run this, you will see some stuff display on your screen while this is going on, and you're going to be also seeing some accuracy results. Okay, so here you may have seen something like 1.0 or 0.99, but this might not represent the final accuracy of your model, but everything seems okay from here. Okay, but we're not going to just take our word for it. We're going to actually confirm that this works as we assumed. So what we do is, remember that we split our data set into training and the testing. There's a reason why we did that. It's because of this. We're going to see why we did that. So if we run xtrain and use this to test, so what this means, if our model is going to make predictions, if it makes prediction, if we supply it the information in X text, then it should be able to give exact result of what is in our Y test, because those values in the X test are actually what generated the Y test results. So we're going to do a little something. I'm going to say Y prediction is equals model.predict. So let's see, predict our X test, and let's see whether it gives us X test, Y test. So whether it will give us Y test, whether this Y prediction will be the same thing as our Y test. Okay, that makes sense. All right. We'll simply look at our Y test. Remember we had one hot encoded this, so let's kind of bring it back to the normal label. So this was our Y test. So let's create a little list that's going to contain all of these, and then we're going to do something like for I in range len Y test. So we are going to say test.append. I'm going to do this so that I can just use a list and compile all of this. mp.addmass is going to help us to convert this back to the labels. Okay, so and then we're going to print test. So let's see what test is. So this is a test, right? 30300231111. So this is the what actually was in the test or white test after we split it. So let's see if the predictions made matches this. Okay, so this makes sense also. So let's call the new list predictions equals list, and let's say for I in range learn predictions. Okay, so we'll just say predictions. Okay, sorry, so this is going to actually be widespread, the variable here. So predictions dot append, okay, np dot addmax, widespread. So it's the from the value, and then let's print prediction, see what we have. Okay, so if you're looking at this, it's almost identical, right? 30300. So this is like a manual way of kind of like checking. I think there's a little stuff that 311, they will have 310. So apart from that, everything is looking so cool. 303, 002, 31. So it's almost looking so identical. Means the predictions. Okay, so that's not what I want to do. So I'm just going to do this right here. What we do right here now is we're actually going to use the standard accuracy measurement function to see the proper accuracy of what has happened here. Okay, so we're not just this is okay. We can just manually look at it and try to say, okay, it's giving us the center. But let's find out the actual accuracy using sklearn accuracy score function. So dot metrics import accuracy score. Okay, so we're now going to say we're going to measure the accuracy right now. So we'll simply say accuracy equals accuracy score predictions and test. So what's the accuracy score on this? And it was good to actually print this. Okay, so it's 0.905. Okay, that's the accuracy. All right, so 0.905, and that's also like 90%. So if we wanted to do this, we could actually say percentage accuracy. So times 100. So we have this 90% accuracy. Okay, so I could even go ahead and just okay, let's do it that way. Okay, so let's see if we can improve this by retraining this model. We can improve the accuracy by retraining the model. Okay, so let's see. Okay. So just improved, So most times, the more you train this, the more its accuracy improves. All right, so now we have 91%. But we're going to just leave this. The essence is not really to train and see how to build and train, but just demonstrating how to build a neural network and then to deploy it in our Django application. Remember, that's actually where all of this is going. Okay, so what's remains now is we need to actually save this model so that we can take it to our Django application. Right here, it doesn't do much good. The good of this is in the inference part of this model. So we're going to save this model to an H5 format, and then we will be able to include that in our Django application. There are actually other formats. You can save as JSON, you can save as PB, and so many other formats like that. But I always just prefer the H5 because it gives me one single file I can always just work with. I don't know, I love simple things actually. So if we're going to do this, it's not rocket science. So uh, we actually have a function already to do this. Remember, we said we want to save this in this folder, save model. So that's where we are actually going to save it. So let's call it my model.h5. Okay. So if that works, we should see our model right here. Okay, so we have built the model, this neural network. If you worked along with me, congrats, you just built the neural network. That's your first time, you deserve to give yourself some clap. We've gone through so many things, including feature engineering here, preparing a data set, and and then we're able to do this. So let's move over to the next segment of the workshop, deploying this in a Django app. The second part of this workshop is where we show how to deploy this neural network we created in a Django app. It is assumed that you already know how to create a new Django project, set up a virtual environment, and install requirements from a requirements text file. Those basics are not covered in this workshop. We'll be focusing only on the part that enable us to deploy our model in a project. Okay, so let's get to it. Okay, welcome to the second part of this workshop. In this part, we are just going to be working and building this interface. I just want to show you what the finished project will look like. So we're going to have this with the phone features where the user can type in the features on their phone, battery power, clock speed, front camera, and so on. Some of these are in float values. And then right here we have all the Boolean features, Bluetooth. This one has Bluetooth, no dual SIM, and so on and so forth. So after all of this, the user is gonna click on predict and then gets that this is successful. It's predicted that this phone should fall on range 2, which is between $1,300 to $2,000. Again, you have to note that these are all just assumed prices for the purpose of this workshop. They don't actually represent actual price range for phones. So it's not like you can just take this and they argued with the seller right now. Okay, but this is a demonstration to show how we can deploy a deep neural network to a Django app. So let's get to the coding. Okay, so the first thing we're going to do is we're going to go to GitHub and clone the repo for this workshop to be able to carry on with the second part. I have this repo samscarlo / PyCon Africa 2020 workshop. So you're going to clone this repo to your local PC to be able to work with me in this second part. So when you do this, you're going to have these directories and files as part of what you just opened. And then the one we're going to be using is the student template. It's kind of like the entire project, inside the project. So the whole of this is the entire project. If you run this now, Python manager, Python server, you are running the entire project. But if you look at the student folder or student template, is like another smaller portion of this project so that we can just work with independently. I don't want to put it on a separate repo, so you just download that. So the one we're going to be opening is the student template file, student template directory. So I'm just gonna use my VS Code and open the folder right here. So the one I'm looking to open is this, the student template. Okay, so once I open the student template, I will have, let's just see what this looks like. Let's see what this looks like right here. I'm gonna start a new command prompt and go right where every of this is. So you're going to create also a virtual environment, and then you're going to install all the things that you have in this requirements folder right here. So everything here, you're going to have to install it on your system. So that's just it again. So all of this, you're going to have to install it. You're going to create virtual environment right now, which I've already done, and install the rest of this. So I'm just going to quickly test out what the page looks like. So let me first activate my virtual environment. Okay, quickly. I'm using the Windows operating system, so filling that on Linux or Mac, you should know how to activate that as well. Source bin/activate. So I'll just go ahead and open the student. I actually named the type project model server. So let me look at what I have here, and then I can just say Python manage.py run server. Okay, so I want to see what the student stuff looks like. I'm checking at this now. So 127. So this is like the project. So the front page is already, front end is already completed. I don't want us to go into doing the HTML. I know this is just going to take a lot of time. So that's why I prepared it, so that we can just work on the deployment side for our model. Okay, so if we have all of these, I'm going to show you also some part of this code so that it makes sense. The whole pages that you saw first is being served from here. I have a form, not a model form, but just an ordinary Django form. I don't have any model set up because I'm not going to be saving this to a database or anything like that. Okay, so that's why I don't have any model configured for this particular project. Yeah, so no model. Okay, but then I have a form that provides all these features: battery power, clock speed, and the labels are there. So for user to enter all of this, which is just what we have seen here. Now I have some boolean values which I did with a check field that could be either true or false, and I kind of noticed that this wants you to always fill it or check this like required by default. So I just kind of disabled that using required equals false, so that when you don't have any of those features, you could leave it empty, and then we'll process it as false from the back end. And so this is where we just add some bootstrap class to our form fields. So this is what is giving us the front end. There are some dummy pages as well that we could go ahead and fill something in, but this is where our interest is at the moment. Like I showed you previously, the completed work, we're going to do and build the completed work right away. Okay, so let's get started with this. So the first thing we're going to do, if we're going to build a completed work, is we are going to create a new we're just going to say Python manage.py start app API. So let's create a new app called API, and that's it right there. So we have this API. So this API is where we are going to integrate our model, because we're going to actually be serving it on Django REST with Django REST framework. And if you look at our model server settings, we already have the REST framework app added, and then our pages. So we're going to go ahead and add API to this. Okay, so then we will also update the URL. So we should have path API, and we should change this to API.urls, and we should change the namespace to API. Okay, so then that means we need to we're gonna need to create an API, a URLs of .py on our API app. So I'm just gonna get the API from here, copy the whole of this, and come to the API app and create a new URLs.py. I'll just paste the whole of this, change this to API. So what I actually need is to have a predict endpoint. So we have this, and so this is gonna be views dot predict, and so this is gonna be name equals predict. So the rest of these are not gonna be needed here. Okay, so we'll save. VS Code, of course, has some Git compatibility. Is part of why I like it. You can just version control your stuff right away from the terminal here. So I could do some Git status and see that I have a lot of on-trend files. Okay, so I'm gonna deactivate that base conda base stuff. So all right, so I'll just do git add just to keep everything going on, and then git commit -m. So I'm gonna call this created the API app. All right, so we have the API app right now. We've set it up in settings and a URL. So it's time we're going to, we already said we're gonna have a views.predict here. So we're gonna create this right away. So this is actually where our integration is going to happen in the views file. So it's just very much important for us. I'm going to check out what's causing errors here. So let's see. Okay, so that's it. Okay, so is where we're going to have all the integration happen. So I'm going to go ahead and begin to import some of the features we need. sklearn.preprocessing. Okay, so we're going to say from sklearn.preprocessing import standard scalar. We're going to say from keras.models import load model, and then from rest framework dot decorators import the API view, and then from rest framework import response, which we're going to use to give the user back the feedback. So we're also going to import numpy as MP, and we'll just have that for now. So let's go ahead and create these add API view. Okay, so let's call this dev predict request. All right, so we're going to get the input from the user from our form. So those inputs are just the rest of all we have in our file: battery power, clock speed, front camera. Okay, so I'm going to copy the whole of this because it's virtually what we're going to be using for this, and Let's see what happens. Okay, so I get that. Okay, I think best to just, this might take longer if we use this. So battery power, yeah, equals the data dot get battery power. So if there is no value provided, we default it to none. So let's also so we're going to do this for the entire 20 variables or features from our phone. So this is going to be clock speed, then we have the front camera, so which is also going to end up as the front camera. Okay, so I just completed the rest of the entering everything about the feature. So I paused the video and just went straight ahead. So if you haven't got up the point, you could just pause it as well and just enter. It's kind of a repetitive stuff, getting all the data from the form we have at the front end. So we have the whole 20 features: battery power, clock speed. Now all the other fields we default to none if is not if the user fails to enter anything, and the boolean part will default to 0 if the user fails to enter something right there. All right, so there is a try statement there, so let's kind of put the exception, part of that code. Okay, so that it doesn't keep hanging as exception. Okay, so I'm gonna do something right there soon. Okay, so let's just keep it at pass. But then after getting the whole of this, so what we're going to do next is we're going to try to be sure that the user have not entered that there is no none in any of those features. So what we're going to do is we're going to create a list containing all of these data we just got from the form. So we're going to have battery power, clock speed, front camera, okay, just the whole of them, internal memory. All right, and internal memory will have mobile depth. So I'm just kind of keeping it in order with the way it appears. The encores, primary camera, pixel height, okay. Then we'll have pixel width, we have RAM size, and then we'll have the screen height and the screen width, okay. And then there's the talk time. We then have the Bluetooth, we'll have the dual SIM, the 4G, and then the 3G, the touch screen, and finally the Wi-Fi. So we just making sure that we have all the thing the user has entered together. So this is going to actually be an if. So we can only progress if there are no none values in features. So if no none in feature, then this is when we can actually begin to progress. Okay, so what we're going to do now, since we don't have any none, if we have no none, if there's a none, of course an error will be thrown somewhere here. So for now, let's just say pass, but we'll get back to it. If not none in features, So we're going to convert all these values to their appropriate data type, because these are just strings gotten from the forms on our website. So we will want to convert all of these to their proper data type. So it's gonna be like typing the whole of this again once more, but to save ourselves that much trouble, I'm just going to just do some hack. Let's make sure the uh, index indents are in order. Okay, so once the indents are in order, so what I'm going to just do is I'm going to be converting some of these to int and some to float. So let me get this and convert these to ints. Of course, I'm not going to do that for all of it, so let me just pick just a few of them. Okay, so I'll have to stop there because we actually need those other ones. Okay, so and then I'm going to convert the whole of these to, it's kind of like some lazy hack you can use to do some repetitive stuff. Okay, so I'm going to remove all of these, all of these, all of these, all of these. Okay, so this goes off. I'm going to do that also for here. Sorry, not here. It's gonna do that for here, and change these to this. Okay, so these are like getting input from the user and then pre-processing the input, because we actually now clock speed is actually supposed to be in float from the data set, and the mobile depth is also supposed to be in float. Okay, so and what we're going to do here is we have to first of all convert this to boolean, because if the user enters, if she checks the button, it's actually going to return on, like a string on, okay, or off. So we have to convert that to boolean, and then before putting that into an integer. So when it converts to boolean, it gives us true or false, which we can now convert to uh, uh, an integer. So if all of this goes fine and the user have not entered any none, so we can process this, then we need to recreate this with the new values. So I'm just gonna just the same thing, but this one will be cleaned features, because I've actually cleaned and processed some of these. Okay, so remember what we did when we were building the model, or we were testing our model we built. We had to scale these values, to evenly distribute them. We also need to do that from the value we receive from the user. So let's perform standard scaling on values. Okay, so we already know why we're doing this from the model session. So we're going to have a scalar equals standard scalar. Okay, so scalar dot fit transform. So we're going to, it's actually expecting an array. So we do that here. So this is going to scale our, I think we should also assign this to a variable. So let's just call it x straight away. So we have prepared our input ready to make prediction on it. So the next thing we'll do is to load the model. So we had Keras for that. So we're going to use model equals load model. Now our model is saved somewhere in our, so we're going to actually need to bring it into our project. So I'm just going to look for where I saved it. I saved it as my model.h5. So where is it? My model.h5. Okay, so there it is. I'm going to open the file location and get it. Okay, so I'll copy this, and then I will need to go to my projects inside the API app. I'll create a new directory. I'm going to call this saved model. Okay, and that's where I'm going to paste this trend model. Okay, so it is right there. My trend model is right there. So I'm going to get this API slash save model slash my model.h5. So that's how I load the model. So we're going to go ahead and make prediction from the model. So we're going to say prediction equal model.predict x. Okay, so model.predict x, and then after making the prediction, we're going to need to convert the prediction back to a label. So convert the prediction back to a label, because it's actually going to give us a hot encoded prediction like 0100 or whatever. So to do that, we just say prediction equals mp.argmax. Okay, prediction. All right, so we're going to now have to send response data. So let's prepare response data. We're going to send the JSON data back with our prediction. So let's call this predictions equals let's put some values here. Status, let's say 201. Message. So this is for when everything works. So we're just gonna say successful, and then prediction, of course, is gonna be what our model predicted here. Okay, so if there was an error, we still have to send the user back this. So we'll just say, but here we're gonna have to give him an error. So let's say it was 301 invalid feature value. Okay, so in this case there's no prediction coming up. Okay, so in this case there's no prediction coming up there. So we will have the last would be for our exception. So if an error occurred, let's call this a 501. Let's just return a string value for our exception, okay? And then no predictions, okay? So at the end of the day, we should return response back to the user. All right, so this is our model. Let's check it out, make sure it's is actually doing this right now. So we are going to, okay, so our let's say Python manage.py run server. Let's see if there's anything broken. Okay, so there's an error here. We can't import response. Okay, so okay, so we're actually supposed to have said dot response. Okay, so that was an error, so we'll kind of break this and we'll do this. Okay, so our server is up. If this took a little while before coming up for you, that's because you're actually loading Keras and TensorFlow. Okay, it tends to be a little bit heavy on some pieces. So let's enter some test features and then check out what our model gives us as a prediction. So let's say we have a battery power 563, we have a clock speed of 0.6, and then front camera 0 is 40, mobile depth 0.6, 150, number of cores let's say 4, let's say 2602 for RAM size, back camera let's just say 0, and then this put it at 11, pixel height 9, pixel width 1004, screen height we can put it at 10 and screen width at 8. Okay, then we're left with some of these Boolean values. We can say Bluetooth is 1, dual SIM, yeah, 1, then 3G is actually 0, this is 1, this is 1, and then there's no Wi-Fi. And so we run this prediction and see what it gives us. Okay, so we have a 200 error. Okay, I think our form, let's have a look at our form, see if we have, okay, so on the templates, let's see if we have added this to our form here. So we have our form, so there's actually no action on the form, so we're gonna have to do that API.predict. Okay, all right, so let's reload this and try this again. Okay, so it predicts successful that this phone should belong to range 1. You see that? So that's between $500 to $750. So if this took time, also you have to know it because you're loading TensorFlow. So that is predicting that this phone is in range 1. Okay, so we have successfully deployed our model in a Django app. But then there's a little tweak I feel we can still do to make our model perform better. If you look here, you will see that we are actually loading our model each time a request is sent to the disk. So this is actually not a very good way to do this. So we're going to load this in an app.py file so that it loads automatically and becomes available and doesn't need to be reloaded each time. So I'm going to put this here as load model. So what this means is I'm just going to have to now bring down the loading back into this place. Okay, so that my model is loaded there. So I will have to import that API. So I'll just say from .apps import API config. Yeah. So we are going to have, so instead of loading this here, we'll just say model equals API config dot model. Okay. So what this does for us is right now our model is always loaded as soon as our project starts. We don't need to load it at each request. Okay, so that's actually what the apps.py folder does for us here. So we just load it here, so it becomes available to us every time. We don't need to keep loading it each time we make a request. So we're gonna try that and see what happens. Okay, so I think I might have, so this is going to actually reload, and then my model should be available to me now. Okay, so this is how you deploy deep neural network or any kind of machine learning model in a Django web app. It's been a wonderful session, and I hope you enjoyed it. So if you have any question, feel free to drop. I'm standing by right now to attend to any of your questions. Thank you. It's been a wonderful session for me. Thank you very much.